NASA has recently been on the lookout for something unique and unusual, and that is a black hole moving swiftly and freely within the Milky Way. This is a unique discovery that contradicts the fact that these cosmic objects are normally immobile. The unusual black hole was identified and measured by what is called the Hubble Space Telescope. It is said to be around 5,000 light years from Earth and has raised interest in astronomers because of its nature. The formation of rogue black holes, the isolated collapse of a star rare, monster stars that are at least 20 times more massive than our Sun, and less than 1,000th of the galaxy's stellar population, are the source of the black holes that roam our galaxy. Gravity crushes the remaining core into a black hole when these stars explode as supernovae. Due to the imperfect symmetry of the self-detonation, the black hole might be kicked and hurled across our galaxy like a shattered cannonball. The black hole that NASA identified and is currently discovering is interestingly unique and eye-catching because it exists in isolation, different from the other black holes that have been discovered. That is, it is not attached to other stars or materials via gravity. Although it appears to be something that is not normal, the black hole provides an opportunity for scientists and researchers to study further in an isolated location and pay attention to it only. NASA's cutting-edge methods for tracking the black hole, finding the invisible tracking, and detecting this unique discovery is a unique challenge on its own. Black holes are known to be light absorbers. Therefore, they hardly stand out against the gloomy cosmic backdrop. However, NASA's Hubble Space Telescope uses a different technological method called gravitational lensing, in which the light from stars behind a black hole is bent by its strong gravitational attraction. By changing the locations of far-off stars in its path, this specific rogue black hole, which is thought to be traveling at a speed of 28 miles per second, allowed NASA to identify it. The black hole's mass is around 7 times that of the Sun, according to precise measurements, demonstrating its tremendous gravitational force despite its small size. By utilizing the Hubble Space Telescope, it gives NASA an opportunity to study, observe, and measure the black hole's mass and speed. In their investigations, 2 teams, one headed by Casey Lamb of the University of California, Berkeley, and the other by Kailash Sahu of the Space Telescope Science Institute in Baltimore, Maryland, used Hubble data. Although the team's findings are slightly different, they both point to the existence of a compact object. Importance of the finding: comprehending the life and movement of black holes. The discovery of this errant black hole, freely moving in the Milky Way, is more like an achievement in astrophysics, as it challenges their previous theories, studies, and assumptions about stars and the galaxy, and how black holes behave. Black holes are often believed to form and persist close to large stars, star clusters, or the galactic center. This lone traveler, however, violates those predictions, leading scientists to wonder what mechanisms might drive an object out of its original location. The importance and significance of this finding might also broaden the minds of researchers about black holes and might potentially provide insight into our galaxy's larger population of renegade black holes. Tens of thousands of these roving black holes are thought to exist in the Milky Way alone, each of which may contain hints about how it formed and the galactic dynamics that led it to become adrift. In accordance with reports, although the presence of stellar mass black holes has been established since the early 1970s, binary star systems have been the subject of all mass determinations to date. X-rays are released when gas from the companion star falls into the black hole and is cooked to extremely high temperatures. Because of their gravitational pull on their companions, the masses of about 24 black holes have been determined in X-ray binaries.